This is the Amp Hour Podcast, released April 15th, 2018. Episode 388. An interview with Earl Sharpe and Collin Kidder. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Earl Sharpe of Machina.
I'm Collin Kidder of Machina.
Welcome, guys. How you doing?
Doing great, Chris. Glad to be here with you.
Yeah. So let's start right at the top. What is Machina?
Well, I guess Machina, the company, is just a company that develops products mostly for the automotive industry. Now, the hardware that we're probably going to talk about today is an automotive interface for interfacing with cars and building stuff.
Okay. So does that mean that both of you are officially car hackers?
Collin,
do you identify as car hackers? Do you have it on your business cards?
Collin,
I
more
do
than
actually
me, but
have.
I suppose so.
Okay.
Yeah, I do actually have that on my LinkedIn. So,
Oh, there we go.
so technically, yes, it does say car hacker on there.
Okay. And so, so we'll get back to Earl and what you would define yourself as. But what is a car hacker, and why would someone do car hacking these days?
Well, for me, I actually come at it from a somewhat different perspective from the other Machina guys. I started doing electric vehicles, and what I mostly do for hacking is we take OEM components out of wrecked electric cars or electric car companies that went bankrupt, take their excess inventory and try to reverse engineer how that stuff works so that we can make DIY hobbyist cars with the components out of OEM vehicles.
Nice. Okay. And so that's does that mean that this is kind of a closed, like cars are kind of a closed ecosystem? Is that kind of the baseline assumption here?
Yeah, cars have historically not been very open, and electric car companies aren't really much more open than the standard car companies. So when we get these components, there's really no information to speak of about how to interface with them properly.
Great, yeah. That at least with the small amount I've heard, and you will probably hear, and the audience will also hear my lack of knowledge about car stuff. It does seem like it's not like there's tons and tons of info out there. It's not like Ford is begging you to open up your car computer and start tinkering with that part. So, Earl, how do you define yourself then if you're not a car hacker?
Well, I am to a degree. Collin, not the master that Collin is, but
okay.
At this point in time, my role is mostly enabling people to do that sort of awesome work. But still, my life revolves around cars in general. So
and so like day to day, I think I've seen pictures at least of you, Earl, in front of cars. I mean, like how much are you guys hands on with vehicles every day? Is it something where you're doing mechanical things and then you plug in some of the OBD2 and use that as a diagnostic, or is it more detached than that?
I mean, for at least for me, it changes week to week. A lot of times we're just working on a benchtop or, doing the normal hardware development process that you're probably all too familiar with. But yeah, we definitely do get dirty and play with cars, pretty frequently.
Yeah, I guess, yeah, what is your car background? I guess, Collin, you kind of talked about tearing apart EVs, but like, growing up in the garage kind of thing, or what's your hands-on background there?
Yeah, no, I literally did grow up in a garage. My father owned a garage for 40 years, and throughout high school, I was working there.
Nice. So like straight up like car talk style, huh?
Yeah, I guess so.
That's about the closest that I've gotten to cars, is listening to car talk on a regular basis, which I still do. Rest in peace to that. But yeah. Okay, cool. Well, so what about the interface then? So I guess I'm kind of jumping around here, but I at least know the OBD2 is the pathway into the car's computer and all the buses and stuff like that. But like, why? You said you're enabling people, or well, I guess both of you are. But like, why do people need to use that on a daily basis for car hacking or otherwise?
I mean, I should also clarify that Machina, we have sort of a dual purpose of helping hobbyists, but also helping companies. So a lot of, what the companies are using it for is to, prototype a product, or, really early prototyping. They might be using M2, which is kind of why we built it, right? Because it is so, it's common to a lot of cars. So it definitely can be used for prototyping lots of different ideas. I guess that's the simple answer.
Okay. All right. So when you say you're selling it to companies, then a manufacturer of other stuff that's hooking into one of the buses would use this as a peripheral just to kind of see what's going on there, or what?
Yeah, I mean the number of stuff that it can be used for and is used for is pretty incredible. I mean the OBD2 port is used from simple things like people monitoring, really simple stuff with diagnostics, to really complicated things where companies are, reflashing the ECU over the OBD2 port. So,
oh wow, okay,
depending on the company, it really varies what they're trying to accomplish, and it's very similar with the hobbyists as well.
Mm-hmm. Well, so let's walk through some of the early stuff then. So the OBD2. What do people usually expect to see there, right? So if someone used the M2, which is the Machina product, like what do you get access to when you use that?
A lot of what you get access to, OBD2 obviously kind of predates these modern cars. OBD2 has been around since 1996, and a lot of what it was meant for is for emissions testing. So in the past, what people expected to find on the OBD2 port would be diagnostic information about the engine for emissions purposes. You could see the engine temperature, timing advance, the mass airflow sensor readings, and things like that. So partly it's used as one of the test aids for emissions certification on cars. And even people say, I mean, you wouldn't want to probably do emissions testing on your own car, but even that same type of info could be interesting to people. Maybe you want to know how hot your engine's currently running, and your dash only has a needle that has sometimes no temperature readings at all on it. Well, the OBD2 port will say the engine's currently 180 degrees Fahrenheit, and that gives you the info you were looking for. So a lot of the readings that you find on it are all primarily engine performance related.
I guess maybe for the beginners, more than beginner, even Chris the beginner, where is this usually located on a car?
So it's usually, left knee area of the driver.
Okay. And so like an access door, or is it just kind of exposed?
It can go either way. I feel like it's I don't know, what do you think, Collin? But it feels like it's more often just exposed.
It's usually exposed. I have seen it be under trap doors.
Mm-hmm.
Okay. Normally, it's still going to be in the same basic spot. I think there's a standard for where it has to be. It's something like within a foot of the driver, or 6 inches of the driver, or something like that. So it's always in a pretty common spot.
Yeah, I mean, sometimes it does take a few minutes to find them. It's always kind of funny.
But it's not going to be like in the roof or behind the driver's seat or anything like that.
No, it
mean,
is mandated.
Good. It's good to know. And it's about what, like 15 centimeters across or so, a couple centimeters high. Like it's not huge, right? I mean, like inch or two across. The standardized port. It kind of reminds me like a Molex port or Molex header.
Yeah, kind of. It
like
is sort of like the old. It almost looks like the old printer style ports you plug into like the dot matrix printer from the 80s.
Oh yeah, that's the
kind of showing my age
right?
there, but
yeah, no, that's what's used on test equipment too. The really old ones is like that, yeah.
Yeah, but it's kind of about that size.
Yeah. Okay. Yeah, it is. It's hardened to say. Is for car stuff always feels like it has that kind of extra layer of needs to survive in all climates and such. So even the test gear. So okay, so down by your left knee. It's interesting that you say when you're talking about what's actually coming out on it. what are some of the protocols that you might see when you're like plugging into this? Like, is it something where could I go and take a scope or a DMM and just probe onto this port or what?
No, it's all. Well, there's a couple of different standards. Modern cars, I believe since about 2009, it's mandated that they use CAN bus for the communications. If you put an oscilloscope on that, all you're going to see is, ones and zeros, basically, just digital signal that looks like nonsense. In the past, they used some other standards, but they're all still pretty similar, where they're more, you could kind of think of it like a serial port, where it's a set type of communications bus and it has data flowing over it in a specific format, but it's not something that you could just look at with an oscilloscope and figure out. It's all kind of encoded a special way.
I mean, there's a few physical layers, and the one CAN bus uses is very common, but there's other ones, and we tried to with the M2 hardware to cover a lot of them. So K line, L line, LIN, and some of the
you
old
gotta explain those.
that sort of stuff.
I've never heard those before. K line, L line.
I mean, yeah, they're just they're other protocols you frequently find in cars. Some of them are not really being used anymore. You don't really see J1850 and stuff like that, but you'll still see a lot of LIN in cars. And I think LIN gets used in other stuff, right? So maybe that one.
Yeah, I would say LIN is mostly used in cars, but I think that it might get used sometimes in, say, audio applications and such too.
I still remember the first time. So like I said, I never grew up using playing with cars or working on cars or anything like that. But I remember the first time, I think it was a Freescale rep. So back when Freescale was still Freescale, they come in to where I was working, and it was someone talking about processors, and they're like, "Well, like, tell me what your specs are. What do you need? You need like CAN bus?" And I'm like looking at him, I'm like, I have no idea what words you're saying right now. and it obviously now I know that there's transceivers that are built into some microcontrollers, and it's probably the Mac, not even the actual PHY layer, right? So it's, but I was just like staring at him like, I don't think I need that.
Yeah,
in the Freescale world, there's a ton of them, right? Like there's tons of Freescale parts in cars, right?
Yes, there are.
Yeah,
yeah, Freescale is pretty common, and yeah, CAN wasn't common, I wouldn't say, until pretty recently. Like I said, it was mandated in cars only starting in 2009, so we're only going on 9 years of cars definitely having CAN.
So you're saying CAN at all, like, and using it as a standard bus at all?
Yeah, CAN was
was
developed by Bosch in 1985.
Okay.
And it was used in engine control units from Bosch starting in about 86.
Okay.
So if you're driving around a 1990 Mercedes, it probably has CAN bus controlled ECUs in it, but it didn't. The big three OEM car makers in the U.S. didn't necessarily follow suit quite so quickly. Mm-hmm. So CAN, it has not been very common until recently in American cars.
Mm-hmm. Interesting. Okay.
And there's a couple types of CAN, right? There's like CAN FD, and I think 2.0 is the most common.
CAN FD is pretty much a unicorn at this point. It technically exists, but no one has ever actually seen it used anywhere.
What does the FD stand for?
Flexible data rate or something?
Normal CAN runs at a single speed, so you'll hear a lot of times say 250 kilobit bus or a 500 kilobit bus for CAN. It's pretty standard.
Okay.
The CAN FD has flexible data rates, so it can start out sending at, say, 500 kilobits, and then when it starts transmitting actual data, not just metadata, it can kick up to 8 megabits per second. So it's far faster in the data portion, and it supports a lot larger payloads. So it's going to be used at any rate for ECU flashing in a car, where the extra speed might be handy if you have to flash, say, a 2 megabyte ECU flash file, then you kind of appreciate the much faster speed.
Right. Yeah. I can imagine trying to dump diagnostic data if you're streaming data back too. That would seems like it would be a little bit more useful if you had a ton of data coming over it. But so what about the actual physical? So people that don't know CAN, I remember when I was learning RS-485, they told me that like this it was pretty similar in the method, except it's not differential. It's single-ended, right, for CAN?
Oh no, CAN is actually differential. There's a couple of different CAN standards. There is single wire CAN, which is single-ended, and single wire CAN is basically just one wire from the differential CAN, and you basically don't use the other wire. So it's the same basic thing, just with less wires.
So then I also remember, where did I learn this? This must have been like at a talk I was at. I think it was. Or no, maybe it was when Rick was on the show. So Rick was on the show and I'm blanking on Rick's last name, but he was talking about some card timing stuff as well. And it was either him or maybe one of the prior guests to that. But anyways, CAN and Lin, it seemed like CAN was like the important engine type stuff. Lin's stuff was like window control. Is that a consistent statement in your minds?
Yeah, that would be accurate. Lin is much, much slower than CAN.
Okay.
I was mentioning how CAN, the standard data rates in a car would be 250 kilobits per second or 500 kilobits per second. Lin is, I think, 19.2 kilobits per second. So it's way slower.
So why do they use it then?
It's cheaper. CAN requires a transceiver, and the transceiver chip, even for an OEM, might be 50 cents, whereas Lin might cost basically nothing to add to their items. So especially for cheap stuff like a window regulator, they don't want to pay the extra 50 cents or $1 premium to go to CAN for a window regulator. So they go to Lin, which is very cheap and can basically be implemented on a processor with no transceivers and just use the processor's serial capabilities. So it's basically free to use it.
So are both of those actually exposed then on the OBD2? Like, is this something that the M2 would actually start talking to through that interface?
Well, I don't think Lin has to be on the OBD2. I mean, Collin, can you confirm that?
The OBD2 standard really only requires that you have one primary means of connecting to the diagnostic data. So in modern cars, that's CAN, and the older cars, that would have been K-line or the J1850, but that's the only thing that has to be on there. So everything else is not really standardized. There could be Lin, there might not be. It just depends on what the car company wanted to do. Quite often, the OBD2 port is kind of there for the car's OEM service center too. If you take your car to your local GM dealer and the windows don't work, they might have Lin on the OBD2 port just so that the technician at the service center can get at the Lin data easier. That would be the only reason it would be there, but it's not standardized as being there.
I remember going to the, you always cringed when the mechanic says they have to plug in the computer, because it's like, oh crap, and they charge you for that too. Okay, so what? And this is an interesting point to me as well. Is that so? It seems like there's tons of processing in cars these days. I don't think that's a surprise to anyone. However, it's not like you plug in the OBD2 and you just get control of the car, right? It's not like it's more. It feels like it's more like it's a mailbox where it's spitting out results from whatever they want to show you.
Yeah, there's a variety of ways. Some car manufacturers basically have a dedicated line from the OBD2 port to one ECU in the car, and that ECU answers the diagnostics related questions that you're asking it, and that's the only traffic that you get. So if you ask what's the current engine RPMs, it will spit back, oh, the engine RPMs are 2,000 RPMs right now. But there's no traffic to speak of unless you ask it a question. Other cars basically have the whole engine control bus right on the OBD2 port, and you practically could send fake data and make it think that the mass airflow sensor is reading a different value than it is, or that the transmission's in a different gear than it really is. So it really depends on the car. Some car makers are more paranoid, you might say, than others about data security.
Yeah, and that's kind of why we, it's not all about OBD2. It's also why we make that what we call the under the hood version, where you can just kind of tap into the bus wherever you can gain access, and other cars are getting like Collin described that situation, and gateways and things like that are making the OBD2 port increasingly locked down. So people are having to find other ways in.
Okay, so maybe can you guys walk us through? Can you just tell us how every car works? I know that's going to be that's not actually what I'm asking. But it seems like there's a ton of computers in there. It seems like the ECU is the main brain of the engine, at least. But is there what is the usual architecture within? Like, who's in charge underneath there, under the hood?
Well, the engine ECU is in charge under the hood. It's reading all of those sensors and calculating the correct spark advance and things. Basically, everything is paying attention to the ECU. Quite often, the sensors are not connected via CAN or anything. The ECU will have dedicated wires for that, so you can't really screw it up too badly. And the ECUs
you said engine ECU, so is ECU not engine control unit?
Well, it is, yeah. It gets to be where if you just say engine CU, it sounds weird. But yeah, the correct term would be ECU because that's engine control unit.
Okay.
In a car, there's usually two main control units. You have the ECU, the engine control unit, that's responsible for making sure that the engine performance is within specifications. And then the BCU, the body control unit, will be in charge of things like making sure that the door locks are working when you push the buttons, making sure the windows go up and down, you can adjust the seats. Basically all the other stuff in the car that's not engine related.
So there's not like one main supervisor then. So is that because the ECU needs to be more tightly coupled, or why?
The ECU is obviously pretty... it's pretty important that not fault. So they don't want that to be responsible for anything that it doesn't have to be, because it's pretty important that your engine, run reliably. You don't want, especially on some newer engines, have variable valve timing and some pretty critical parameters. If the ECU goes out to lunch and sticks your valves open, that's not going to make you a happy person.
Right.
So the ECU is very robust. A lot of times they have multiple processors in there that are all running in lockstep, checking each other. It's pretty hard to make the ECU do the wrong thing because the car companies are very paranoid that the ECU keep running. A lot of times they've got, like a 100,000 mile engine warranty. You don't want the ECU to blow your engine up at 60,000 miles and they owe you a new one.
Right. Okay.
So they kind of it's kind of compartmentalized that way, where the body control unit will take care of the non-mission critical things, and the ECU might take care of the more mission critical things. And you may even have some other mission critical ECUs, well, if you want to call them all ECU in a way. You might have some other mission critical computer systems, like the ABS is probably its own computer system because it's pretty important that your brakes work properly too, things like that.
I guess I'm just surprised that there's not, I don't know what I'm expecting here, but I guess I'm surprised there's not like some, I guess what I'm thinking of is it sounds like the ECU is akin to a microcontroller or an FPGA where it's like really, really in the weeds and really, fast timing, fast response, just control loop kind of stuff. And then it seems like you said, ABS is another one in that vein of tight control, whatever. I guess I'm surprised there's not like the equivalent of like a Linux level supervisor, running in the dash or something like that, just saying, here's, I mean, I guess, there's probably some stuff up there, but I always assume that the higher level stuff would be in control in that case, but maybe the human is that computer? I don't know.
They kind of, actually in a Tesla, you'd almost be right. The Tesla Model S, that big 17-inch center display has a computer back inside of it, and that computer is the central brain box of the whole car.
Okay.
And really does control everything else. The drivetrain is controlled by the center computer. The ABS is controlled by the center computer. So in a Tesla, that is literally the case, where there is one computer where basically all of the communications networks terminate in that one central place. Not necessarily like that in every other car. I mean, there's usually going to be one system that's kind of responsible. Maybe the body control module kind of oversees everything else, but you've got a lot of autonomy too. If you're driving down the road and the body control module blows up, the ABS module is still going to keep working, trying to make sure that your brakes work right. And the ECU is still going to keep working, trying to make sure your engine works right.
So it's just about interoperability between all these things.
It's kind of a redundancy thing. You don't want one thing to be able to break and destroy the car. They all kind of run in their own separate domains.
I mean, the feeling I'm getting, at least from this initial conversation, is that there's not much standardization either, at least between manufacturers. I'm sure within manufacturers there are, but...
Yeah, I wouldn't say there's a whole lot of standardization. I mean, no one wants to completely reinvent the wheel, so the way that one company did it is going to be pretty similar to the way the next company comes through and does it. Mm-hmm. But you can't necessarily say that that Ford is going to do things the same way that GM does. They just don't. There's different ways of doing things, different ways of routing the buses between every manufacturer.
Yeah, I mean, I don't think they necessarily want standardization. I mean, that data is worth a lot, and the complexity of getting it and building products for it and that sort of thing is, certainly a value to the manufacturer, and they don't really want to give that up.
I mean, I guess the thing that I think about is smaller companies kind of have to do that, right? They have to be more standardized. Someone was telling me recently that they bought a cheapo router from China and it just had OpenWRT on it. And it was because that company was not even close to big enough to write their own firmware. Whereas if you go to a Netgear or someone, they're writing their own thing because they can and they feel they have to, right? And that's kind of what I feel like it's part of. It feels like there's a lot of historical stuff here that I'm missing too. But just big companies doing big things kind of feels like the feeling here. Yeah,
I mean they're building themselves a little bit of a barrier to entry or a moat or something like that.
Yeah, right. But the downside sounds like that it's so now as a third party provider, you have to deal with every flavor that's out there, right?
Yeah, it is. It's almost mind-boggling sometimes when you try to get into that. As a small-time company, it is difficult to provide support for a wide range of vehicles for that very reason. Every vehicle is going to be different, and in fact, in terms of communications, like the way that the communications on, say, CAN work, the car companies feel free to switch that between model years, between models of cars.
Oh, really?
That makes it really tough. I mean, in the past, there was maybe a more robust DIY hobbyist type of system. People would quite often try to put Ford motors into a Chrysler car, and it could be done because the motor was pretty much its own island, so to speak. But now that's a little harder because even though the ECU on, say, a Ford motor is mostly just controlling the Ford motor, it's still looking for communications with other stuff on the car. Say it might be looking for a message from the ABS or traction control module, so that if the traction control module detects that you're slipping, it tells the ECU to not let you have any more torque than a certain limit so that you quit slipping.
Yep.
So it's always looking for messages. Now that makes it really tough to put, say, a Ford motor into a Chrysler because all the messages are different. It would be like dropping an English speaker into China and expecting that you could get along fine.
Well, from what you're saying though too, it sounds like even year to year. I mean, like that part or systems aren't compatible even within the family of cars or trucks that you're talking about here because they might not have the same standards.
Yeah, they may not. I mean, it's not that they do that every single model year or anything, but
like families of model years,
do
right?
it. Yeah, when you hear, like, let's say GM came out with this new vehicle and it's the second generation of that vehicle, that's pretty much an indication that probably they changed all the communications in there too. I know for a fact that Tesla is pretty notorious for that, because that's one of the areas where I have done the most work. Between model years, or even sometimes for basically no reason at all, Tesla will just up and change things on the CAN bus. A message that used to mean one thing will now be gone, and a different message took its place with a different format. So that can be kind of frustrating sometimes.
Well, I'm sure at Tesla and maybe even the bigger companies now, I'm sure when people's stock options start to vest, they move on, and then the new person has to prove themselves. So what better way than to mess with all the CAN bus messages, right?
Yeah, it could be.
Yes, right. Yeah, a little bit of churn, but definitely some job security. It's funny too, because we can make fun of the Tesla engineers. They're probably not allowed to come on here and talk to us. In fact, I know one, and I even asked him on here. He's like, "Yeah, no way." Well, it sounds like so it sounds like people that even within companies. Then I can imagine an engineer at Ford who has to trying to talk to a ABS system from the ECU. You know, for some reason the documentation isn't there. It sounds like they have to. It sounds like within all this stuff, reverse engineering at the very least is baked in, because you have to figure out what the hell is this new message that I'm seeing, right? It sounds like that's just a thing you have to deal with.
Yeah, I mean,
Yeah, for us it is.
When companies come to us and they want us to help them, build hardware and whatnot too, we often end up having to help with the reverse engineering stuff, or find someone that can help.
So what does that look like then? So a company comes to you and says, we want to talk to this new module, blah blah blah. You're gonna go and help them to do that. Where do you start? I mean, reverse engineering to me is like black magic. But where do you start specifically with cars?
It really comes down to discipline and whether we're trying to do it with the sort of core team we have, or find someone that maybe specializes in it. There's so many different specialties within car hacking, I guess, that depending on what you're doing, you might be looking for someone specific.
So when you say specific, you mean someone that's on a certain model year or type of car, or like Collin does EVs, or is it what is it?
Yeah, exactly. I mean, I think it goes multiple ways. Collin might be great at certain types of EVs. Other people might specialize in certain types of attacks and certain tactics for reverse engineering. I don't really think we're only a year old, so maybe we will kind of get into a better rhythm on that. But so far, it's just kind of been doing whatever we can to make the job work. So far, the hardest part really has been, acquiring cars that you can work on is pretty challenging too. And I hear that from pretty much everyone.
You mean like just because of the cost, or because you have to get access to certain parts of the car, or what?
Yeah, I mean, if you're trying to, you can build a product without necessarily having the car, but then as soon as you're trying to integrate it, then you need to actually have, at least a benchtop, sort of kit, or, in a lot of cases, the whole car. There's not a whole lot of firms that sort of specialize in renting out, cars to people that are then going to reverse engineer them.
Interesting. I guess I don't know what I expected here. I guess I didn't realize that firms were doing this kind of thing in the first place. So maybe could you give us an idea of, I don't want any specifics because I'm sure that's sensitive, but like the type of a company, like give me an example company that would come to you. Is it like an end product integrator? Is it like someone wants to make a new car seat cover, or is it who's coming to you? What kind of companies are coming to you?
I think it's small to medium. A lot of them are kind of newer startups that are trying to accomplish something and raise money. We've been successful there a couple times, which is always fun to be involved in sort of a new company. Some of them are companies that are they're established companies, but that division is sort of a startup, so they don't necessarily have a team built out around, that function, or maybe it just, it doesn't make sense for them to, build out a team around that. If it's going to be sort of a one-time thing, or, very, infrequent. But again,
But are they making like end parts, or are they making other things that, like, I guess I don't understand what these people are making. Are they making like new car stereos that need to talk to something, or new engine timing things? I don't.
Well, I mean,
I'm kind of lacking knowledge of what goes in cars.
And it depends on the. Like I said at the beginning, there's the automotive range of aftermarket products is pretty incredible. So, it might be something, performance-y or sort of, creature comfort sort of thing. Obviously, there's a big push into IoT these days. So, a lot of the, if we're looking at products like our M2 hardware, automotive dongles and automotive interfaces, a lot of that's going to be sort of, IoT, make your car smarter for whatever purpose it is. And, and even inside of those IoT dongles, there's a ton of markets when you consider, or, a ton of different applications when you start to consider, consumer as well as commercial, uses for adding the internet.
Okay. So yeah, I have seen some of that stuff in the past. Like, so one that I think about is like I want to know how many miles I've driven for business expense, right?
Yep.
And so someone like that, so if I was going to make something like that, I want to know how many miles I drove for my business expense so I could track my work vehicle. I would come to you and I'd say, can you help me to decode the messages coming out of this OBD2 port? Is that kind of the idea?
Yeah. I mean, and some of those, the original ones were very simple. They kind of worked on the standardized data that I think Collin was talking about earlier. Definitely now with sort of second generation ones coming out, they're trying to push a little farther into the unstandardized stuff. But it's, I don't know if we've necessarily mentioned this, but the OBD2 port, can read and you can also write to it. So, So like if someone's flashing an ECU, but you also see, simpler functions where people are, trying to push commands back into the car. For example, I must, talk to someone once a month that wants to start, that wants to build, a car sharing program. So they want to be able to, remotely open the doors or remotely, disable the car, or, whatever is kind of involved in what is the big one, Car2Go and those sort of, car sharing programs.
Yeah, those are actually great, I think. So okay, so to use Collin's example from before, if it's like dropping someone who speaks English into China, you guys would be like the translators at that point. You'd be like helping people figure out how to navigate the language. Is that kind of the idea?
Yeah, when we do it, I mean, we're wrapped up in a lot of hardware projects these days, but we're definitely getting more involved into that side because, at first when we started, and we kind of wanted to stay sort of, the hardware side, product development. But, we've sort of come to realize that, it's a pretty niche skill set, and we're going to have to do some of that sort of stuff.
Okay, well, let's talk about the hardware. So what is the M2? I think we've said it a couple times. What actually is it? I mean,
I think of it as a modular sort of automotive interface. It's kind of a development platform, really. We've got a processor board, an interface board, and then that socket on the top, which follows the XB standard, so that people can, add whatever boards they want up there, whether it's a modem or GPS or, all the different flavors of those boards that are out there, Bluetooth and Wi-Fi.
Yeah, those I saw the XB standard. It's pretty much like serial bus, pretty much, right? I mean,
yeah, it's that 20-pin socket that was started by Digi, who's another Minnesota company here. Or popularized at least. Very popular in the industrial space for many different things. Probably because of that pseudo standard. So and that's why we picked it. Then on the processor board, you're gonna have we got the SAM3X from Atmel. And we went with that for that first processor board, just because it kind of spans the spectrum. We thought, or at least pretty well. Beginners can use it because it does work with the Arduino platform, since it's what you find on the Arduino Due. But it's also it's one of their, or at the time at least, was one of their faster chips. So it could keep up with the automotive market pretty well, and Collin already had a little experience with it. Then on the interface board, we've got all these interfaces that we've been talking about so far. A couple of CAN bus, single wire CAN, and LIN and K-line and J1850, and I'm probably missing a couple.
Oh, okay. So the modular piece you're saying is you actually, so you separate out of the processing from the physical layer stuff so that you could swap it in. You find a new card has that J-line or the what's the one you said, the CAN FD,
sure.
Some new unicorn thing like you said.
Yeah.
So you can just swap over to that. Then.
Yeah, I mean certainly our curtain processor couldn't do CAN FD, but as we roll out more processor boards, we could, and we plan to, make more interface boards that are compatible with all the new stuff that's out there as well. And, I think people have been talking about FlexRay a bit on the forum. Certainly CAN FD is interesting. And there's a couple others that are, popular. I mean, automotive ether is another one as well, kind of. We all knew that was coming, I suppose.
I suppose so, yeah. Eventually they'll put an Ethernet jack on everything before it goes wireless, right? And you've already got wireless, yeah.
Yeah.
So why didn't this exist before, I guess? I mean, it seems like you said it's only 2009 since a lot of stuff had CAN bus on it with OBD2. Why isn't this already out there?
I mean, I think, there to a degree it was out there. There was definitely some Arduino boards that had, CAN bus. I think, Collin, didn't you write a CAN bus library for the Due? There was to a degree other things that were doing, lots of these pieces. And then when you look at industrial tools or professional type stuff, there's tons of stuff. Certainly more expensive, but that's what people were using, and still are.
Okay, so it's more about accessibility and getting it in the hands of
making it
more people,
making it a commodity, really.
Yeah. So why? So I guess to follow my line of why questioning, why not higher level? I mean, is it super timing sensitive that you need to have it embedded? You need to have like tighter loops. Why not do a BeagleBone Black or Raspberry Pi or something?
There's certainly lots of car hacks that do utilize those things. Making it compact is one thing. And we are planning on kind of. We've been working on a little project. We're trying to be, more open with the stuff we're working on these days. We made a breakout board so that you could kind of, replace the processor board with a Pocket Beagle, which we're all pretty excited about.
Yeah.
Yep. So that'll definitely kind of, give you a lot of the functionality that you would get with the BeagleBone Black and a CAN cape.
Yeah, so I guess, and maybe this is a question for Collin then. So I don't quite understand. Okay, so now we have this board, we had the M2, it's plugged in. Then what? I mean, like maybe I'm asking higher level or higher power boards, but like maybe it's not necessary. Like is it just logging the existing data, or what are you actually? What are you doing?
Yeah, I mean, I think we're taking part in the conversation with the car, I guess. So there's a set standard for how you communicate with it, right? And that's kind of what Collin was describing earlier.
But maybe it would be a good to just get an example of what someone would do with this kind of thing.
Oh,
then.
I
so
see.
Is it yeah? So you plug it in and you're like, I'm going to. I guess you said read the engine temperature. That's like one thing, but
yeah.
What else? What else would someone do with this?
Well, so there's what you get automatically. This sort of stuff you can find on Wikipedia or all over the web. It'll tell you what different IDs that are standardized will do. That's the Elm 327 type stuff. Maybe you've run into one of those. It's kind of what the cheap like Chinese $10 dongles and the apps like Torque. That's kind of what they utilize, is that known set of information.
Okay.
Collin actually developed a really cool program that would kind of be the next step. It's called SavvyCAN. And this helps you sort of pick apart and reverse engineer, basically a data log from the car and try to, figure out what those, what the unknown IDs are up to. So that's generally where we go next.
Kind of sounds like a Wireshark kind of style of things, where you're like classifying, like you said, you're classifying different messages, and then you're pulling the payloads out of them. Is that kind of the idea?
Yeah, more or less. It is. On CAN, messages are sent. The metadata is mostly an ID. When you see a message on CAN, it'll have an ID from 0 to 2047. So there's about 2048 different message IDs on standard CAN. And when you see a message, usually it's keyed to that ID. And in a certain car, that ID means something. For instance, on a Tesla, ID 15 is the steering angle returned from the steering controller. So if a message with an ID of E comes across the wire, you know that the data is going to be steering angle. And on CAN, you can have 0 to 8 bytes of data on each message. So on Tesla, most messages are 8 bytes, whether they have to be or not, and the steering angle is returned with 2 different scaling factors in that message. So you know that E, or 15, or E in hexadecimal, means steering angle. But if you have a whole bunch of messages flowing across the wire, you don't know what they mean yet. So the program that I wrote, SavvyCAN, is kind of meant to try to help you with that. If you see, say, message 137 comes across lots of times, SavvyCAN would let you look at the data bytes that are in subsequent messages as it's being sent and try to see what they do. Do the bytes seem to form a signal that looks like RPMs? Does it form a signal that looks like it could be the engine temperature? You're kind of looking at what do the data bytes look like? What could they mean? You're trying to categorize.
Do you ever just put them
messages
up on screen as a chart and then go press every button? Is that like something you do sometimes?
Kind of, yeah. Sometimes one of the things that we'll do for reverse engineering, let's say that we do want to know engine RPMs and you want to find the message that does it. Mm-hmm. What we'll do is start recording traffic, and then you have somebody mash down on the accelerator, say 2 or 3 good times, and get it up to 4,500 RPMs. Now you go back to the data and start graphing the different data bytes on different IDs that you saw and see if anything looks like it's got big swoops that seem to match the pattern that you hit the accelerator in. So kind of do it that way, partially visually, trying to determine what message could be the data we're looking for.
The fun thing to do is to start playing things back and see what lights up, right? Turn it into a Christmas tree.
like actually writing back to the ECU or what?
Yeah, or let's say that you think that you found the engine RPM message. A fun thing to do might be to start sending your own message and see if the dashboard switches position to match the messages you're sending. If you think that you've determined the correct way to format RPM messages, you might try to set the RPMs to 7,000 RPMs and see if the dash says that, even when the engine's idling at 900. Yeah. So you can kind of check yourself that way.
Okay. Yeah, that's a great idea. So I guess how much is this like you're storing and capturing and then you have to play it back, or how much is it just streaming? Is it just there's too much data to stream it all out?
There's a lot of times CAN bus messages will be sent about every 10 milliseconds. Mm-hmm. Sometimes it's 100. So you might have 100 messages a second flowing for a specific signal. That is a lot if you were just trying to stream it out and look at it as it's streaming by. But we do that sometimes. There is the capability in my software and in other people's software to sometimes just look at data flowing over the wire as it's going and just stream it past and see if you see anything that looks suspicious, you might say, or that looks like what you're looking for. But we kind of do it both ways. Sometimes you might look at the data in a streaming situation, and sometimes you might store it. But the nice thing about CAN is 500 kilobits is still only about 50 kilobytes. So there isn't, the whole traffic on the bus might be 50 kilobytes a second. You could store hours of data and not take up any hard drive space.
It seems like there would be a lot of data coming from a car in general. So why isn't there more, I guess? Is it just a limitation of the CAN bus?
Yeah, the CAN bus is able to send, on 500 kilobit bus, you can send about 4,700 messages per second.
Okay.
So that sounds like a lot of traffic, but that's everything on that bus has to share those same time slices, if you will. And you can only send that much traffic. So if you had 10 things on the bus, they could only send 470 messages per second each before they saturate the bus out.
Right. So again, I guess this comes back to my question of who's actually in charge of saying, sensor 1, you can only send 10 messages per second, or sensor 2, you can only send 100 messages per second.
Nobody, basically.
So does it ever get overloaded?
Yeah, the car, the people who designed the car know the limitations of the bus, and so a sensor that's on that bus will only try to send so many messages per second. Usually, everything on the bus is usually sending in a time loop, you might say, where a sensor might send every 100 milliseconds, and it's never going to send its status messages faster than that. It's timed with a timer, and every time the timer ticks off 100 milliseconds, you send a message. So for the most part, the car knows how many messages per second it's liable to see because everything's timed. And usually they use far less than 100% bus load. Normally in a car you see about 1,800 messages per second on a bus that can do 4,700. So they're trying to shoot for under 50% bus utilization for times when, say, an emergency happens or when you're sending the diagnostic requests. All that stuff can be on top of the 1,800, and as long as you don't get crazy, it would take quite a bit of extra traffic to go from 1,800 to 4,700 and saturate everything.
This is all starting to sound very similar to my distributed control system days. Like, it sounds like specifically in the same way that I was assumed that temperature sensors would update like 1,000 times a second, but it's like, no, well, you don't need to know the temperature every, second or 10 seconds. So you just turn that down manually, and you when you're designing the whole system itself.
Yeah, it's more of a system design perspective at that point, where the bus doesn't get overloaded because when they designed the system, they knew what the bus limitations were, and they know certain sensors, ABS probably does send every 10 milliseconds. So it's 100 times a second you're updating ABS stuff because that's important. But RPMs might only send every 100 milliseconds because 10 RPM updates per second is more than plenty.
Right.
And they know that ahead of time.
Yeah. Okay. And I guess this also brings up the question of what is actually being sent, because I think it came up in the context of one of the times I was listening about car hacking, and they were talking about what you can control and what is actually coming back from all these computers, right? So like what is the level of access that people have to the data that is actually on the bus, and the control they can exert over it? Well,
it's a kind of complicated topic because in one respect, CAN sends messages with a certain ID, and the IDs are associated with certain data. But the interesting part about CAN is that there's no actual concept at the low level of who is sending that data. Normally, everybody has their own compartment, and sensors only send messages that they were meant to send, and ECUs only send messages they were meant to send. But there's nothing stopping someone from sending messages that somebody else on the bus was responsible for.
Right, you were just talking about that even, where you said you could play back a message and say, "Hey, I'm the RPM sensor. Here's what the RPM is," right?
Yeah, there's nothing to stop you from doing that in CAN. Anybody can send any message at any time for any reason. The only thing that keeps the Wild West under control is that the people who designed the car knew the design aspects and the domains for every piece of hardware, and make sure that their hardware only sends the correct messages. It's their responsibility at that firmware level to make sure that each device is sending what it should. But the bus totally doesn't validate that. Anybody could send anything.
So are you saying that if I took an M2 and I plugged it into someone's OBD2 port, I could reenact that scene from the Batman movie where like Danny DeVito as the Penguin is driving the Batmobile remotely? Could I do that? Because that's been a dream of mine.
Not entirely. I mean, we have tried to do some. I've tried before to do some playback on a car where the existing messages are still there. A lot of times, it just confuses the computers when they see the regular traffic is there. Now you're injecting traffic that says to do something different. So what the receiving end sees is do this, no do that, no do this, no do that, no do this, back and forth so rapidly that it gets confused and says, well, which one do you want me to do?
Well, so like on the Tesla though, could you rip the steering wheel out and the sensor out and then just drive by wire like that? Is that
essentially
really...
Well, I don't remember if the Tesla. Well, probably some of the newer ones you actually could do that.
Right.
The older ones might not allow drive-by-wire, but the newer ones that are drive-by-wire, yes, you could pretty much unplug the unplug the control unit for the steering sensor and play back anything you felt like and drive the car.
Y'all get creeped out by that, or?
I mean, there's a couple of companies, right, trying to do self-driving cars, sort of with cars that weren't meant to, or weren't originally envisioned to be self-driving. But I think, like Collin was saying, there's a lot of conflicting messages, and so they end up having to do a lot of filtering, right, of the messages that they're competing with.
Yeah, the only way to reliably override a control system in a car is to unplug that control system and then fake being the control system yourself.
Right, and having a good enough knowledge of what it's actually supposed to send so you don't put it in some weird corner case state, right? You
would have to virtually perfectly emulate a device that you don't have the firmware for, and that's pretty tough to do.
Right, but at the very least, you could put an air gap between them, right? You could take the steering column off, plug it into an M2, transmit it over Wi-Fi, account for the delays, pull it back out, put it onto the CAN bus, and then, drive the thing, right? That's kind of the idea?
Yeah, you could more or less do that.
Why haven't you guys done that yet? That's pretty crazy. I mean, like, it sounds like, especially because, thinking about, like, the 1970s, like, muscle car, like, there's nothing electronic in there except for, like, headlights and, like, fuses and stuff like that. And, like, relays, maybe. But... yeah. Man, everything is just controlled these days, huh?
Yeah, basically everything is computer controlled in a modern car, which has its blessings and its curses. Like you said, it can be scary to think about. Cars are starting to come out now where the steering angle detector is literally, you have a steering wheel attached to nothing. Just a sensor that tells you how far you spun the steering wheel, and it's a piece of electronics that's turning the actual wheels back and forth.
Right.
So you're kind of trusting your life to that kind of electronic hardware.
Yeah.
Holy crap. It's kind of weird, cars do, we're very much so working on, cars that are putting this technology in. So I guess it's good for us, but it is a little weird when they kind of start to feel like iPhones, and they get faults and they go into limp mode and stuff, and it's kind of annoying when that stuff starts to get in the way.
Right, it's kind of annoying when you crash into brick walls a bit too.
Yeah.
So that, I mean, I guess you guys probably have clients that are doing this stuff, but is anything changing on the CAN bus? I guess my mind always goes dark right away. Like, I read these dystopian novels all the time, and like, like, is there anything happening to encrypt CAN bus traffic, or even just to verify that sensor A is talking to sensor B, or sensor A is talking to ECU A kind of thing, or is there anything in the works for that?
Well, I kind of glossed over this. Quite often on anything that's super critical, like steering position sensors, when they send the data, and usually it's not encrypted, but what they'll do is send 1 or 2 bytes in that message will be what I would call like a security or a checksum type byte.
Okay.
But they don't use, like CRC5 or CRC8 or anything that you could easily do yourself. They'll use they'll try to come up with as sneaky of a encoding scheme as possible for those security bytes that usually kind of encode the message that they sent. The other bytes will be turned into they'll use special operations and then come up with a special security byte, and the security byte or 2 is tacked onto the end of the message. Now, everything that's supposed to receive that message knows how to also calculate the security byte.
Right, exactly.
And if it's not the correct one, it will ignore it.
Yeah.
So
but then that's where replay attacks come in there as well, right? Because you could just, if it's not encoded, you could just do a replay and try it again and be like, oh well, see what works and what doesn't work, right?
Yeah, they try to stop you from that a little bit by putting counter bytes in there as well. So every message will have an incrementing counter byte, and the counter byte is part of the security byte. So if you can't, you can replay it then, because the replay will have the correct counter and correct security byte. But if you don't know how to calculate the security byte given the message and the counter byte, then it's just all that much harder to calculate the security byte, because there's a constantly incrementing counter that's adding entropy, you might say, into the data. So they try to mess you up that way, but
I mean, this sounds like it's like 20 years behind, though, to be completely honest. I mean, this sounds like in terms of encoding and encryption and all that, it's not like they're encrypting stuff or anything. It's just they're just adding some other obscurity. I mean,
there definitely are a couple startups that are trying to offer the OEMs encryption for their existing systems. I think I'm not 100% sure on this, but I heard that the reason the car companies aren't biting is because they kind of can't because of legislation.
Really? Interesting.
And I'm not 100% sure on why they haven't.
I mean, well, I think you'd run into the same thing that like John Deere has that whole case against, well, not case, but like there's a lot of pushback against them because they encrypt all of their parts that have they have to get verified and talk back to servers and stuff like that, and that really hurts farmers. I assume with all of the car shops that are out there as well, like same thing happens, and people don't want to put in aftermarket parts, right?
And I mean,
they most the same thing. It's funny you mentioned John Deere like that. Go ahead and try once taking a transmission out of a wrecked Mercedes and put it in a different Mercedes.
Oh, really? Same thing?
You can't.
Wow. Okay.
They most certainly they do the same thing John Deere does. Car companies will encode, especially parts that are most likely to be stolen, like motors, transmissions, and things like that. They literally do have. It's not really an encryption per se, necessarily, but they will have kind of like a startup sequence where when the transmission starts up and you go to start the car, the ECU,
it sends like a challenge or something like that.
It's called challenge response. Yeah. The ECU will send a challenge, and if the transmission can't send the correct response back, the ECU will never ask it to go into gear. So you're stuck.
Ooh.
I mean, I was talking to a rebuilder the other day who he rebuilds cars, and he has to actually find someone to rebuild the original airbag because he hasn't been able to figure out how to how to get the car to recognize the one it didn't come with.
If people don't know, I think the reason is because they're worried about aftermarket components and losing their margin, because a lot of these companies make money on the long-term supportive parts, right? That's like part of their business model,
right? I heard Caterpillar only makes money on that, basically.
Oh, really? Like the machine itself is the loss leader
Yeah,
and the parts
the
of the
service
business?
plan.
Yeah, I think it's like that to some extent with cars even as well. They say that dealerships make all their money on service calls, which is part of the reason, I'm mostly into electric vehicles. That's part of the reason for a slow uptake of electric vehicles, because they don't break hardly ever.
Right.
The
Yep.
service center won't get any business, so the dealerships are like, well, we sell cars basically at cost. Why would I want to sell an electric car at cost when I'm not going to see this person for 5 years?
Yeah. I don't make money selling brake pads. Yeah. Huh. It's a crazy business for sure. And I mean, like, and I feel it feels like the same thing where the initial costs, the expectations for users as well, right? People, when they go to buy a car, especially an electric vehicle, like there's a lot more upfront cost, but people don't really think about that for the long-term support of the car, right?
Yeah, I mean, they're coming down even in price too, so maybe the upfronts are even sort of becoming comparable.
With electric vehicles, they're more expensive up front. You have less maintenance, and gas is expensive. So to some extent, over the life of the car, it depends on how long you want to keep it. But with an electric car, filling it up is about $2 in electricity, whereas filling up a gas car could be 60.
Yeah.
So
right.
you save some money there, but still, for quite a while, it still wasn't really much of a value proposition. You could spend $15,000 more buying an electric car, and you weren't likely to spend $15,000 in
Right.
gasoline.
I mean, and the other thing is, right,
Yeah.
you end up spending a lot of money on batteries occasionally if you keep it for, say, 20 years or something. At some point, there's going to be some giant spike in spending.
So, all right. So let's go back to the M2, because this is like the platform. It's all around building, or it's a modular platform that you can use to get started. If someone was interested in just taking a peek at what's going on in their car, and I do know from our survey recently that like 60% of people are listening in their car right now. So pretty good audience for that stuff. How would they get started with the M2?
The best way to start, and I think most people do, is kind of, using Arduino and putting Collin's SavvyCAN on there just to kind of see what's going on with the CAN bus and just kind of get familiar with it. With getting familiar with car hacking in general, I always, suggest people pick up, the Car Hacker's Hand Guide and check that out. I think that's a pretty good, introduction to a pretty broad topic like we've, started to go over here today.
Yeah, that's good. I think so maybe at the beginning they would just be monitoring what's going on, taking a look at messages, and would you expect then that they would, I guess they could use this stuff for tuning, and what else might they use it for in the end of the day?
Yeah, I think at first you're mostly logging data and just, trying to understand how your car works really. Certainly once you get a little bit more, once you start to get some understanding there, you can, take on some little projects. You're trying to think of like a really, simple one. Like the RPM is standard information, and a lot of cars today don't come with with a tachometer, so you could theoretically make your own or something like that.
Okay.
But yeah, I think that just logging the data and trying to figure it out is where a lot of people start. And your car being kind of unique, there's definitely some. You'll need to do some work as far as just kind of figuring out what's special and going on in there, I guess.
Mm-hmm.
But yeah, I mean, there's lots of little communities kind of spread around that are working on all sorts of different projects that you could get involved in once you have some understanding around what you want to do really.
So it sounds like with like one of the M2 breakouts or something, you could maybe wire it to a secondary display that you could stick on your dashboard or something like that. Look at the temperature, look at the internals of your car without retrofitting a huge new display or something.
Yeah, there's actually a kind of neat thing. I don't think I've actually seen anyone try with the M2 yet, but one of the things that people use on the OBD2 port is a heads-up display, because most cars don't come with one, but it would be kind of neat,
yeah,
to take data that you wanted to see and display it up on your windshield. So, you could kind of, given our example that we keep using of RPMs, let's say you don't have a tachometer, you could, make your own little heads-up display thing with an M2 and literally fire out a big graphic of the tachometer right onto your windshield as you're driving.
Yeah. Yeah, that's a cool idea. I've seen. I saw one like heads-up display thing recently. It was like a flip-up reflective one, but I think it was just showing like directions or something. So it wasn't anything engine related.
I mean, I was driving a Corvette the other day, and that had a heads-up display that you could kind of, move around where you wanted it on the windshield. So they're becoming more common. I think Nissan had one in the early 2000s or even late 90s or something, just for your speed. That just kind of, reflected off the dash basically with a mirror or something.
I know we're kind of getting up there in time, but I feel like we have to do it after last week too. Like we were talking about the self-driving cars and a lot of the sensors and stuff. How does that change now? Like as people are doing more self-driving car stuff, does that impact what either of you are doing, or does it change the nature of what's on the CAN bus, or are those completely different systems?
Well, I mean, I think it's gonna there's gonna be more worry about car security, and certainly a lot of people that are doing car hacking are, especially the people that are doing it for a living. A lot of them are security experts that are trying to help OEMs close loopholes and stuff like that. So I really think that it probably will make things more important as we move towards trying to make the self-driving car and whatnot, and obviously that's got to be very secure to external threats. There's probably going to be a lot of the same car out there, right? As people stop caring so much about brand and differentiation of cars, and really just are kind of looking for the efficient transportation. There's going to be a lot of, it might become more standardization than we're experiencing today, so it's going to need to be very secure.
I don't know if Madison Avenue will ever let us not care about cars. That's what that's my response to that one, because I think that like there's a lot of advertising dollars that are behind like, oh, you are your car, Yeah, no, I agree. I think there'll always be brands and whatnot. I think Bob Lutz, was it yesterday or something at SAE, he made the argument that the brands will become sort of, the Uber or the Lyft. As they start to own and buy cars, they won't, won't want Mercedes branding on it. But I agree. I don't think that Mercedes will ever, completely disappear. They'll probably start, competing services and that sort of thing, and they'll still be a luxury or whatever that people pay more for. So does that mean that if you had a LiDAR sensor on top of a car, then would that be on a completely different system, and then that whole computer system would talk through the CAN bus to the rest of the car for a retrofit, or would it be like a LiDAR system puts data onto the bus as well?
I mean, we haven't really worked with one of those actual cars yet, but
okay.
I mean, even in I think we talked about it a little bit. There already are cars that have 6 CAN buses or something like that, so I'm sure it'll be something like that.
Well, also as well, when with self-driving cars, they're going to faster buses. I think it was Earl mentioned FlexRay in passing. That's a competing standard to CAN bus, but FlexRay is a lot faster. I think 10 megabits per second, so it's getting up there close to Ethernet. So as you see self-driving cars and this autonomous systems, a lot of times the autonomous system is sending so much data so rapidly, you couldn't do that over a standard CAN bus where you have 50 kilobytes per second of transfer speed. So they're going to things like FlexRay and Ethernet, and that's where you're seeing the autonomous systems. So there is kind of a transition in that respect to newer, faster buses that can handle the kind of load that, say, a LiDAR sensor puts out.
Yeah, I guess right now, I mean, again, like my experience is only in distributed control systems, but it's all like human scale kind of stuff is pretty slow. Like, you update something 10 times a second, it seems like it's real time to most humans, right? it's what 30 milliseconds is like the light window or sound window, or when you start to being able to hear delays. So yeah, it's not that fast. Whereas a computer is like, I'll take all the data you can give me. So
yeah, you know, when you're talking about a LiDAR sensor or something, it could be updating the distance to objects 1,000 times per second or 10,000 times per second.
Right.
And when you get up to that kind of data speed, you need something faster than CAN to send that kind of data to the system. Not to mention that, you know, like Tesla is actually doing autonomous driving by looking at video. So you obviously aren't sending video over a CAN link.
Right.
So you're getting other bus systems in there that are much faster for that kind of data.
Okay. Yeah, so that was my question too. So even at like a reverse camera right now, they would be, I guess infotainment's kind of a whole separate system anyways, but anything with a camera in a car right now, it's going to be a separate system, almost guaranteed.
Yeah, a lot of times systems like that are connected to, you know, they're connected to CAN bus for command and control kind of, but they have a separate bus too for audio-visual things, or in an autonomous system, a separate bus for the actual flow of video data or LiDAR data. But they still have command and control probably over CAN, where there's still something, say the ECU is still telling the LiDAR sensor that what it wants to see and things like that.
Got it. Okay. Yeah, because that's the other story that I remember in the news the past couple of years. There was the Jeep hacking where they did that, but they were able to access the CAN bus, but it was via the supposedly firewall infotainment system, right?
Yeah, it's not uncommon in these cars for there to be a lot of CAN buses, and to some extent they try to segment them away so the important stuff is not usually user accessible, but there's always going to have to be a gateway system somewhere that can talk on both buses at the same time. So basically what they did in the Jeep was, I think, hack the radio or something.
Yeah, it was. Yeah.
And the radio had access to the other bus. So once they got access to the radio, they could hop over and piggyback onto the bus that was really important.
Yeah, wasn't a lot of that through like the OnStar system or something?
Yeah, it was.
Yeah, I think so.
Yeah, it was something that's user accessible. I remember that.
Yeah.
Well, I'm glad that. I mean, that sounds like, honestly, it sounds like all of this stuff is why you guys are doing what you're doing. Anyways, you're enabling, more visibility. It's coming either way, right? It's either people are gonna, do it on their own and do it maliciously, or there's more visibility, and then they're like, oh yeah, we should probably secure this stuff. So it sounds like the Machina and the M2 is its own reward there.
Yeah, I mean, I think it's an interesting dual goal where we kind of want people to be able to control their car and mess around with it and repair it and tinker with it, but also you don't want anyone that doesn't own it doing anything. So certainly right. Sort of a dual purpose, I guess.
I'm actually amazed that there is so much access onto the CAN bus, that there is, like, I guess from I don't know much about security, but I know certain things shouldn't be allowed, right? And it seems like a lot of stuff's allowed. So it'll be interesting to see as that stuff changes over time. Yeah,
I mean, I think things have definitely gotten harder even in the last few years. So imagine it'll continue to get complicated.
It's kind of the dual-edged sword of what we do. So we're trying, especially what I do, where I'm trying to take OEM components and use them in other cars. Well, security was virtually non-existent at first, even in electric cars, because nobody knew anything about it. It wasn't publicized, and so they were able to be very lax with their security. Nobody really thought much of it. Now that there's visibility with the Jeep hack and some other things, and even with Machina, I mean, the more visibility we get, the more the OEMs take notice and say, maybe we wanted to secure these things a bit better, because now everybody and their uncle is hacking on their cars, and who knows what they're going to do.
Right.
So it's a bit of a double-edged sword, in that the more visibility you get, the more they lock it down, and the harder it makes your own job.
But probably for the best, right?
Probably.
Certainly.
Right. Your day-to-day pain is everyone's is everyone's benefit. Well, there we go. We've just found the treasure chest, and that is, we should probably use that as the end of the show here. So, where can people find info about Machina and M2 and everything else?
Yeah, I mean, we have a website, machina.cc, Twitter. I think that's just machina.cc. But a lot of the development stuff kind of goes on the forum. Collin's always on there. We're all on there, I guess. But stop by there if you're interested in this sort of thing. And yeah, I mean, we're at a lot of the conferences too, the ones we've run into you at, and others as well. Mm-hmm. So awesome. Hopefully we'll run into a lot of your listeners.
Any upcoming that people should keep an eye out at?
I think Will's at a couple of the B-Sides conferences, Iowa's this weekend maybe, and we'll definitely be at DEF CON and some of the more popular ones. We're always at SuperCon. I don't make it to a ton of them, but I don't think Collin does either. But Will's at 20 plus conferences a year, so. Okay,
and that's Will Karuna, right?
Yep, that's the guy.
Okay. I'm trying to get better at using last names. I've already, And the Rick, Rick Alter was the one that I was trying to remember before.
All right.
I looked it up in the meantime. So, all right. Well, great. Thanks, guys, for being on. And we'll definitely post links to all this stuff. And this has been a really good, it feels like it's just this is the beginning. Like, I could feel myself, like, asking more and more questions. And, like, as I kind of got a feel for what was going on there. So, it sounds like an exciting field to be in. So, thanks for telling us about it.
Yeah. Thanks for having us.
Thanks for having us.
All right. Well, we'll see you at conferences, and we'll talk to you soon.
Bye now.
Bye.